Good morning, everybody. It's time to start. Welcome to this Symposium on Science and Society. My name is Mark Sahner. I'm the director of the Institute for Science, Society and Policy here on campus at Ottawa U. And the other member of the organizing committee, Gordon McCurt, is right here. I think most of you know him. He heads up Situating Science, which is a SSHRC-funded cluster. We also have on the program committee Jeremy Gielen, who is in the room over here, and Emily Tector, who, I don't know if she's in the room, back there. So just so you, that's the organizing committee. So let me just tell you a little bit the concept of the conference. And I just want to start with saying two sentences about the institute I'm directing. This institute is 3 years old, and we start with a very broad, and still pursuing a very broad theme. It's called Science, Society and Policy, and the topics we are covering are not only science policy, but also evidence-based decision-making, which arguably is part of science policy, and also technology governance. So it's not just focused on science. And I wanted to tell you that because the symposium also covers all these elements. Now you may wonder if that's a great idea to invite experts. This is an invitation-only event here, and have such a huge scope, because normally it's difficult to work together across languages. But I think this is really worth the experiment. And I'm motivated by something Buzz Holling said. Buzz Holling was the president of the American Ecological Society, maybe 10, 15 years ago. He wrote in an editorial that in the discipline of ecology, there are really two kinds of cultures. One culture is very reductionist, the other one very integrative. And the issue that arises is that the experts, the most reductionist members of that ecological community, what they do is they end up with very good answers to questions which are quite unimportant. On the other hand, those who are very integrative, holistic, they will tackle the right question, but give a very vague and sometimes useless answer. I noticed that this almost the same thing was said 20 years earlier by a French scholar, Joël de Rosnay, in a book entitled The Macroscope. And this was applied to the social sciences. So in psychology, sociology, the same effect happens. So I think it's quite universal to have this dilemma that if you take on the whole, you have a little bit of a difficulty getting to a clear answer. But if you take on the fragments, it just may not matter so much. So with this kind of idea, we ended up having a huge diversity of topics. The way we want to do it is we want to draw it together by having one symposium question, which you all have seen. So simplified, we simply want to see how to manage, improve the interrelationship between science and society. So you're invited to take apart the question, you're invited to analyze. It would be really nice if you could come up, at least as part of your contributions, either as speakers or question or workshop participants, addressing either answers, the low-hanging fruit on how to improve the interface, how to react to acceleration of science and technology, or at least provide a vision on how the whole system should be seen or managed. That would be our goal. So the way we want to do that is we have keynote speeches, we have breakout sessions. At each of the events, even last night, even tonight at the Play Copenhagen, there will be rapporteurs who have to look at the contribution of the workshops, the breakout sessions, in the light of this symposium question. And we will distill all this and have quite a long workshop tomorrow. We have a shorter workshop tonight, quite a long workshop tomorrow. And then we end the whole event with what we call influencers panel, which is a group of people which is also, again, very diverse. But we believe each of them has a real ability to see results in a part of the real world. So it's a bit of a reality check. It's also a further extension of perspectives. So I just wanted to say that our goal would actually be that feel free to have a very academic discussion. That's what we're here for. But try to see why it matters and how to get to this symposium question. So this is pretty much everything I wanted to say as a general introduction, but Gordon, I invite you to expand or criticize, start to question the question, or simply to introduce the speaker. Yeah, okay. Thank you very much.
Twice as old as you. I am the director of the Situating Science, as Mark pointed out, the strategic research cluster funded by the Social Sciences and Humanities Research Council of Canada to bring together historians, philosophers, sociologists of science to examine science in its history and in its cultural and social context. And we've been running for about 6 years now, doing partnerships with all sorts of organizations to expand the field of science and technology studies and make it relevant to academia and to the public. We started in 2007 after a 2-year preliminary period, and we expanded, this being our last year, and I've worked on multiple occasions with the Institute for Science and Science Policy, and it's exactly the area that we wish to move in as we conglomerate all of our successes into a follow-up for the cluster. We hope to have a partnership going in a year or so on one of the themes, the major themes of the cluster, which is science and its publics. This has always been a golden thread, red thread, running through all of our issues of understanding science and in context. And it beautifully, the whole cluster started with a lecture series on trust in science. And the keynote speaker for that lecture series on trust in science was Sheila Jasanoff, speaking about science and its publics. I think that was actually part of the title, was Science and Its Publics. Sheila is well known to anybody working in the field and outside of our field, a leading scholar in the field of science and technology studies, founding chair of the Science and Technology Studies Department at Cornell, and has many accomplishments. Served on the, I think there's a biography left on the table, so you can go through it and underline all the good parts during the talk. I will just state a couple that are important for this meeting. She's served on the board of directors at the American Association for the Advancement of Science, president of the Society of Social Studies of Science, numerous books, a dozen or so, all from controlling chemicals, studies of the Bhopal disaster, the Fifth Branch, Science at the Bar, one of the leading contributions towards the study of expertise in the judiciary, Designs of Nature. After 20 years at Cornell, Dr. Jasanoff left to go to the Kennedy School of Government at Harvard and is now the Pforzheimer professor of STS at that school. She is also the founder of the Science and Democracy Network and has examined everything that will be talked about at this conference, from the regulation of toxic substances to the role of expertise in a liberal democracy. Today, she's going to be speaking on science and its publics, dependence, disenchantment, and deliverance. Thanks.
Thank you, Gordon, for that introduction, and thanks to all the organizers of this event for inviting me and for all of the arrangements leading to it, especially Emily, who was extremely patient, trying to organize an almost impossible itinerary from Boston to Ottawa, not apparently the world's easiest connection. Anyway, so it is, I mean, having watched this network or cluster of activities come into being, it's a great pleasure to be here at another moment in its evolution. And I hope to address some of the kinds of issues that you've been talking about. your story about integrative versus reductionist ecology calls attention to the fact that my last slide actually is full of questions. So I'm not even going to give answers, whether they're relevant or irrelevant, but maybe that'll be a jumping off point for thinking about some other sorts of things. So at least south of the border, and to some extent, I gather, also in Canada, there's a widespread perception that science and technology are in trouble in some way, that they are under attack in ways that are unprecedented. Of course, you seem to be living through the George W. Bush years in some respects here in Canada. I had always thought that Canada was far too sensible a society to ever allow itself to be dragged in the directions that America periodically gets dragged into. But there we are, and one's political predictions are never reliable. So where does one begin to address this question of whether science is in trouble and how we would even know it? So in particularly Anglo-American countries, and to some degree in the European Union as well, there's a fetish for doing surveys about what it is that people think about science. It's a little bit like, what do people think about Miley Cyrus and things like that. On all the kinds of indicators that are produced, it turns out that science does not look to be in trouble, depending on where you look. So the British Public Survey Organization, Ipsos Mori, has done reports periodically on the public appreciation of science. And from their last report, which was their fourth report, there's this kind of diagram that, this is the latest version in showing weighted averages of preferences for various things, so that 80% you see on the top is 80% agree on the whole science will make our lives easier, and down below you see an even larger number on the bottom right, 82% agree scientists want to make life better for the average person. So it's nice that people think that both in terms of what scientists want and what they actually are likely to achieve, people have a high degree of confidence. 88% agree scientists make a valuable contribution to society. So these are not numbers that are consistent with claims that science is in trouble in some way. And scientists themselves enjoy a very high degree of regard. So when they've started measuring not just what people think about science, but what they think about scientists, for each of the statements, please could you tell me the extent to which you agree or disagree, the top line is percentage who agree scientists make a valuable contribution to society, and that has stayed relatively constant. As you see, if anything, in 2011, it's mildly higher than it was in 2005. And agree scientists want to make life better for the average person. Note, this is the average person, so it relates to ideas about citizen science, which you heard about last night, I gather. So, there 82% agree that scientists want to make life better for the average person. So it's not that the out-of-control guy or gal in the lab coat who's sort of releasing dangers into the world. That is not the going image of science or scientists in these kinds of polls. And that's for the UK. If you turn to the US, the standard place to turn is the National Science Foundation's Science and Engineering Indicators, and there's the famous Chapter 7, which is about the public understanding of science. And then from the 2012 Science and Engineering Indicators and the executive summary of that document, you see various statements that are, again, consistent with a high degree of interest in and support for science. So Americans have consistently expressed interest in S&T, with 41% reporting they were very interested, 50% reporting they were moderately interested. Well, if you add up those numbers, that's quite a lot of people. Americans in all demographic groups consistently endorse the past achievements and future promise of S&T. So there's both hero worship of past scientists and promises of the future. Support for government funding of scientific research remains strong. Now, this is something that scientists themselves are always going on about, that the miserable state of public understanding of science undercut support for the public for the funding of science and so on and so forth. This is Dan Greenberg, the famous Washington journalist who covered science and technology for a very long time, wrote in his book about this myth, that there is just no correlation, and yet scientists keep on acting as if there is a correlation between what they take to be public misunderstanding of science and what they take to be lack of support of funding for scientific research. There just isn't evidence, and when you talk about evidence-based opinion, it is a little bit shocking to me that members of the science and engineering communities keep on reiterating these views when, in fact, the survey research, which they themselves like to rely on for other purposes, indicates very little in the way of a correlation there. And a majority of American scientists accord scientists very great prestige. Ratings for engineers, some of you may wish to take this on board, are lower, but nonetheless better than for most other occupations. And as you know, those occupations these days include being an elected representative of the American people to the Congress of the United States. So, you know, scientists and science are doing a lot better. So why the worries? Well, these same indicators begin to offer maybe a slight glimpse or window into the answers. So here's one cautionary note. From that same list of what the majority of Americans believe and don't believe. So a majority of Americans favor medical research that uses human embryonic stem cells. However, Americans are overwhelmingly opposed to reproductive cloning and wary of innovations using cloning technology. Well, as you know, this has been a starting point for mobilization among life scientists to some degree, pointing out that the reason that the public gets worried about these things is that they're speaking in the wrong terminology, that they should not actually be saying things like cloning technology. There isn't any such thing. If you really were a life scientist, you would speak in other terms. And if scientists could only dictate the terms of the debate, the actual language, instead of these fearsome phrases that people coin for themselves or that the media regurgitate, like cloning technology, then we would be home free. And because people don't get the specialist language, which is what scientists want to put in their mouths, therefore you get misunderstanding. So already in a statement like this, you begin to see some of the underlying fissures and fracturations of the surface agreement between scientists' needs and desires and the public's needs and desires with regard to science. This, I think, is an interesting other survey from the Pew Research Center, again reported very recently in 2013. So this is, the reason I think this is interesting is that the place above all where Americans are, US Americans are strongly supportive of funding for research and research itself is in the life sciences and technologies. And why? In part because of lengthening of life. When you hear sort of standard speeches praising the achievements of science and technology, increasing longevity is almost all the time one of those achievements that people point to. So here is a place where people were asked about biomedical advances that would produce greater longevity. And they were asked whether they personally want medical treatments that allow the average person to live decades longer, to at least 120 years. And then they were asked, what do they think most people would prefer? And there's an interesting asymmetry there between the two things. So they personally, the majority of people, 56%, would not want themselves to live 120 years. But they think most people would want to live 120 years. I mean, so 68% attribute to other people a desire that they don't themselves have. So you see there a kind of ambivalence. And the quality of ambivalence, of course, is not well measured in survey instruments. I think that one of the analytic tasks for people who are engaged in science and society activities is to understand the nature of ambivalence better and to understand what in a multivalence kind of world accounts for ambivalence in people's attitudes to things. And then here is a diagram, another graph, that is more concerning perhaps than anything else I've shown you so far. So this is, through 2010, a mapping of people's political positions in the US and their level of trust in science. So the topmost graph is people who consider themselves political liberals. And you see, if anything, a slight upward trend since 2002. So again, you can sort of wonder about why that is. But those are the years in which the huge politicization of science happened in the George W. Bush administration. The middle one is, which shows a downward trend, is moderate political, the political moderates are the triangle in the bottom, and the conservatives show that steep downward trend in the middle. So conservatives and moderates are both trending down toward virtually the same kinds of levels of distrust, having started at similar starting points back in 1974, which is not all that long ago. And now they're wide apart by quite a number of percentage points with regard to the variable of trust in science. So what's going on there? Why this gap? And of course, scientists and engineers and the leaders of the scientific community have a ready answer. They call it public lack of understanding in science. They call it media-driven distortions of the scientific evidence. And so the attribution is to non-right thinking among people. So clearly the first graph, the topmost one, is the one that would be the right one if people understood science as scientists would like science to be understood. All right, so all of this is based on a set of assumptions, and what I want to do for the remainder of my talk is to question some of those assumptions based on cases that are widely known in this audience and in the public in general, but I want to present a somewhat different reading of some of these cases. All right, so trust in science and trust in scientists. You know, science is a very big domain. Even ecology, as we heard, has people approaching ecological science from different perspectives. STS people like to think a lot about the actual work that goes into doing ecology, for instance, and somebody who studies a field site and goes back to that same plot of land over and over again every year is doing a different thing in work terms, in attachment terms, in analytic terms, from somebody who's doing remote sensing using satellite-based data, surveying large swaths of territory, and yet all of this can be ecology, and you can study one species and still be an ecologist. So, you know, science is a wide variety of things, and when we say science, I think we have to get a little bit more down and dirty about what we are talking about. So with regard to climate science, we're usually talking about the Intergovernmental Panel on Climate Change, which is the body that has pulled together the most authoritative statements about climate science in known human history. And one can therefore ask why people should trust them. And there are only a couple of thousand of them. And in any case, who is a climate scientist is a post hoc achievement in a sense. You know climate scientists because they get roped into writing the IPCC reports, not because there are climate scientists out there whom you can identify using a Geiger counter and they are the climate scientists of the world, right? So why should we trust them? So there are different theories for why we should trust them, corresponding broadly to theories about the validation of science in general. The first one, which is often called truth to nature, is that well, we should trust them because they're depicting reality. But as everybody knows, there is a question about the kind of data being used and what are signals and what's noise, and you have to try to understand how much convergence is enough convergence to show that what we're getting now is a true signal and not noise. And there's always going to be interpretive flexibility. And even if you agree that a phenomenon like this is happening, there are many, many, many uncertainties about how much, when, in what places, to what degrees, affecting what pieces of the weather system. Even within the short history of climate science, we've actually gone through a major name change from global warming to climate science, and we've gone through an understanding that it was a rise in the mean temperature around the Earth, which is what global warming implied, to something that says it's much more erratic, much more situated, that in a city like Boston, you may end up getting a very cold spring, and yet the overall temperature of the Earth may be rising, and extreme events is what we should care about. And new discourse has entered the vocabulary of climate scientists themselves. So this question of the reality to which climate science corresponds is complicated and not straightforward, not linear, not achieving the kind of convergence towards a singular truth that many people expect of science, and which scientists, by the way, think the public ought to believe about science to a great extent. What about a different kind of more sociological reason why we should trust these climate scientists? The great sociologist of science, Robert Merton, in the middle of the 20th century, posited that one reason to trust scientists was that their mode of work promotes trust, that they are themselves honest to a degree that is not seen in other social institutions, not because they're virtuous people, but because their stock in trade depends on their being honest in some sense. But it turns out that it's very difficult to find disinterested scientists these days. Science needs money to support it, and it doesn't matter, in a sense, whether the money is coming from government or the money is coming from industry. There is interest all around. My much respected good friend, climate scientists, do hang out with pretty important people. And, you know, there is a kind of cachet that comes from sitting on the President's Scientific Advisory Committee that does not come from, say, sitting in this room on a morning in Ottawa. I mean, you know, there are stakes and rewards. There's a reward structure, there's a ladder, you climb that, there are interests. It is not a value-free domain, no matter what people tell you. You get to go on cruises to Antarctica, and you go to Aruba to have meetings to discuss things. I mean, you know, these are things that would strike that same average person who believes that scientists have a lot of prestige as living a lifestyle that few average people have in them the capacity to live. Moreover, it's not universal in the sense that Robert Merton claimed about science, because we're talking about an interdisciplinary domain with very different styles of measuring things, monitoring things, representing things. The work products that go into making climate science are hugely disparate, and so on and so forth. So some people think that it's not just correspondence to nature to some degree, not just scientific integrity to some degree, but the strength of the consensus. If this were false, you would get more disagreement. But consensus can come about for all sorts of reasons. Some of you in this room may be old enough to remember the horrible story of Jonestown in South America, where close to 1,000 people committed suicide following a cult leader. Cults happen. They happen within science as well as outside of science. Epistemic community is the nice name we give to a set of people who end up believing the same thing. But the fact is there is resonance, positive resonance and feedback when you're in a community and wishing to believe a set of things, and the extent to which this plays back into one's unwillingness to hear dissenting opinion is something that needs to be taken account of as well. If you're working in a community, you're not making entirely independent judgments. So last, but not irrelevant, is that this is the closest thing to democratic scientific development that we can think of, because it is not just any old consensus, but a consensus that is representative according to agreed upon norms of representation. It is transparent, again, according to agreed upon norms of transparency. Of course, we have to ask second order questions about who agreed anyway, but nevertheless, this is a different way of justifying it. And it's accountable, again, according to agreed upon rules for how you ensure accountability through wide peer review and wide accountability to the public. So it will not surprise you to learn that I, with my training in law and to some degree public policy and regulation, believe that the democratic virtues part of it is extremely important. And if anything, that is the piece that I would key my own set of trust feelings upon, not just the other three, which is not to say that I consider the other three irrelevant. I just think the other three, the top three, are not meaningful for public science used for public purposes unless it also corresponds to the democratic virtues. So this is not the argument that one hears climate scientists giving for themselves. And in that respect, I think they're acting to some degree as their own enemy. Climate scientists themselves prefer the argumentation that it is all about truth to nature and it's all about the strength of the consensus. And here are references to some famous articles and famous writings that reinforce exactly that view. Now, if you think that it's the truth value and the consensus that justify our trust in science, then you have a theory of why dissent happens. And it's very easy to claim that dissent happens because of corruption. And this is a book that has become extremely famous, and what it portrays is people buying science for their own purposes. Here are the authors. The lady on the right is Naomi Oreskes, and the gentleman is Eric Conway. And it is a sign of the potency of the book that Naomi Oreskes, as of this fall, is a professor at Harvard. And the book has been extremely influential. In fact, somebody sent me a link to an article in the Chronicle of Higher Education that you can look up today, an article about how defender of climate science comes to Harvard. Okay, so defender of climate science, but I'm not interested in whether somebody is a defender of climate science or not. I am interested in why we should trust a set of predictions about the future of the Earth that will affect every single person in this room and for generations to come. That, I think, is worthy of high stakes, not whether we trust climate science or not. That is a surrogate measure. But I'm much more interested in the why question about trust. Why should we trust them? And I don't think that a good answer is that dissenting opinion has been bought by corporations, even if the evidence is strong that corporations buy science to suit their interests. So I am not denying that there is corporate corruption in the making of knowledge. It's just that that is not the full story. So ClimateGate taught us to be a little bit skeptical of the buying science argument as the be-all, end-all, and the only explanation that we need to worry about. It taught us certain kinds of things about the robustness of the consensus. And I think one thing that we learned is that the story is much more complicated. And the point that I want to make for the rest of the talk is that science is not value-free. It is value-laden in all sorts of profound ways. Not that it should not be value-laden, but in democratic societies, we need to, indeed in any societies, we need to understand what that value-ladenness consists of and where we, the people, have to have some say in the values that are incorporated into the very doing and propagating of science. So climate science does not only state that a certain set of greenhouse gas-induced changes in climate are going to happen. They also force us to think about the future in radically different terms from the ways in which humanity has thought about the future for a very long time. And I call attention to the shift in scale making as one of these ways. If you go through the scales at which we think about our environment and the future, climate science in and of itself, through the kinds of claims it's making, is forcing us to turn our gaze to a different scalar dimension. So with regard to nature, weather has become climate. It's the easiest thing to understand, where we're being forced to consider changes in what's happening in weather, which still concern us, by the way. It's not that we can forget about the weather. I had to make a concerted decision about whether I would stick my umbrella into my bag when I left Boston on a sunny morning, and I looked up Ottawa, and they gave me a misleading report that it was going to be raining, and I did bring the umbrella, and every ounce counts when you're traveling by air. So, I mean, you know, so local weather does matter. But at the same time, we're forced to look at this and say, oh, it's a warm fall, what's happening, and it's also climate. Space, it's no longer sufficient to be talking about geopolitics in older terms that were current for 200 years. It's supranational. Time, this is very, very important. Most people don't think in terms of far distant futures. And the very important science of economics has conditioned us to say what happens 10 years out, let alone 100 years out, is irrelevant. We're going to discount it. So here is a science extremely powerful in public policy that's telling us we should not bother thinking about the future a certain number of decades ahead. And then here is natural science saying you must think about that future hundreds of years ahead. So between economics and climate science, there is a disruption, both equally scientific, both equally relevant to policy, about the way in which you should think about time. So pity us poor average persons who are supposed to ask ourselves the question, what is the temporality that we should be thinking in and thinking of? This is not a joke. I mean, sometimes with time, I show the picture of Stonehenge to suggest that this is one of the oldest recorded artifacts of human creativity, and it's only about 5,000 years old, and we have no clue what that thing meant. And yet, here's Sandia National Labs commissioning from people around the country statements about how to warn people about nuclear waste at 10,000 years hence. I mean, there's a sort of perverseness almost about forcing people to think in these kinds of terms. What about people themselves? Lots of psychological experiments show that we are more attuned to people close to us than to people distant from us, and yet here we're being asked to take over stewardship for unborn generations and for the whole population of the earth. And last but not least, the scale of governance. You know, subsidiarity, the principle of subsidiarity, which is a piece of all constitutional government, says rule at the place that is closest to the people. In one way or another, this is articulated into many modern constitutions, and yet climate science is saying rule away from the people, thinking globally. Okay, so it does say act locally, but I think there's a bit of a mistake. I mean, if you're thinking globally and acting locally, you're still acting on the global thinking. So it's forcing you to be displaced in a certain sense. So these are things that climate science is asking people to do. And they're not in the domain of, is it truth to nature? These are in the domain of values, they're in the domain of governance, they're in the domain of who should care about what. So what climate science and climate governance asks us to do is to buy into what I would refer to as a regime of discontinuities. Our ordinary inherited capacity to imagine the future as being continuous somehow with the present becomes disrupted, and we're asked to think of a future that is actually broken from the present in the kinds of ways that I'm suggesting. There are other disruptions we can no longer afford to if we're real environmentalists. Think of nature as being out there, it has to be part of culture. We can no longer think in terms of humans as the only thing we need to care about, because humans are integrated into an ecosystem, and maybe the most dangerous piece of that ecosystem we're led to believe. We're projecting time beyond the capacities of human remembrance. We're questioning the nation state and its capacity to summon up the expertise to solve problems. And with all of that, we're necessarily challenging the objectivity of science, because science has wrapped up in it all these value dimensions. All right, so that tells a much more complicated story, which the corruption of knowledge line, that narrative, does very little to address these other kinds of concerns. All right, let's turn to another very powerful story that scientists tell about the problems with public trust in science. And this is the story of agricultural biotechnology. All of you have heard of it over at least a decade, if not more. It took particularly virulent form in Britain, but all over Europe there is widespread distrust of agricultural biotech scientists and of crop biotechnology in general. And this is dismissed in the US as a paradigm example of the public not knowing, not understanding science, and therefore rejecting it. However, if you look at a series of outbreaks around crop biotechnology in the United States and look at the explanations that have been offered by the scientific community for these eruptions, as it were, then you see together a packet of stuff that adds up to something like GM denialism, a term that I believe you have never heard of, but this time the shoe is on the other foot, in a sense. So one of the early demonstrations was by a Cornell scientist who showed that the monarch butterfly's larvae suffer from exposure to pollen from genetically modified corn. And this was a good study whose quality nobody has ever challenged. What has been challenged is the relevance of that study to the real world. So industry says, yeah, good study, but it just has no bearing on the actual behavior of monarch butterflies who never come into contact with the GM corn in the way that this study presupposes. The story of Ignacio Chapela and GM maize, in which he claimed that the modified trait was finding its way into native species in Mexico, is another case. This one did bring forth accusations that it was not good science. Each of these stories one could dwell on and talk for 50 minutes about just that, but I won't. The point is to go through the cases and show that each one has dragged forth a separate and different explanation for what went wrong. Starlink and Taco Bell, this is a kind of genetically modified corn that was authorized for use in animal feed, but found its way into tacos of Taco Bell, where it wasn't supposed to be, and that has been dismissed as a case of regulatory failure. Protogene, a case of a pharmaceutical, a nutraceutical plant that ended up in the wrong plot. It wasn't supposed to come back the following year, and yet it did. And that was chalked up to bad agricultural practices. You all know about Percy Schmeiser even better than I do, because this was a Canadian case. And that, it was treated as a case of patent infringement, not accidental cross-contamination of Percy Schmeiser's non-GM crop by Monsanto's GM crop. There's a case involving GM golf course grass, and it escaped out of the golf courses all over the place, but it was treated as not a problem because it actually caused no harm. Now, each of these, you can see, involves an unauthorized release of one sort or another, an escape of the genetically modified variant into places where it shouldn't be. And yet, instead of telling a sort of holistic story about maybe we're wrong to assume that these things cannot be contained and maybe we should be thinking differently, each one has a targeted, specific explanation that's offered from the industrial side. So, you don't have to be a trained lawyer to see this as a case of special pleading, and you may wonder then about, how else this plays out in the world. All right, so on the US side, GM is being treated as something that needs to be propagated all over the world. But for that, you have to construct the rest of the world as needing American science. And this is a powerful image that shows how the rest of the world is being constructed. A lot of these battles are, in fact, playing out in a place called Africa. Now, lest you think that this is a figment of my or a cartoonist's imagination, you can turn to Science magazine, where in 2003, the then head of the Rockefeller Foundation, one of the chief proponents of GM in agriculture, wrote an article, co-authored, talking about Africa's need for GM. And that article features a constructed representative of Africa known as Mrs. Namurunda, who, and it's quoted there, represents a composite of situations existing in Africa. So, you don't need a great deal of post-colonial theory to be a little bit worried about a statement like this and that it's appearing in Science magazine. And you don't need to be a student of the Bible to read here a set of plagues of Egypt, only they're descending on poor Mrs. Namurunda. And then the article in question represents, with tabulations of the improvements wrought upon her crops, a scientific-like demonstration that the need for GM agriculture is strong and that it is all over Africa. So questions that don't get answered, I mean, for instance, there's a huge revival of the golden rice debate going on in the media right now. But what doesn't get answered is, why would the things that got in the way of shipping vitamin pills to little children not also get in the way of GM agriculture, especially when we have Nobel Prize-winning work like Amartya Sen's showing that famines are not the product of lack of plenty, they're the product of institutional failure at all levels. So why is it that institutional failure is not presupposed for high-tech agriculture, even though institutional failure runs rampant in all of these places about maintaining a sort of minimal degree of public health protection? So given that, it's not surprising that you get, all kinds of outbursts of opposition, and you get it from scientists. So this was sent to me yesterday, but that's on any day I lecture, I can sort of talk about yesterday's news, and it's relevant. So this was sent to me by, obviously, somebody who is skeptical about GM agriculture, but see what it says. Repeated recent claims of a consensus affirming the safety of GMOs are misleading and, quote, may place human and environmental health at undue risk and create an atmosphere of complacency, states Dr. Angelika Hilbeck, chairperson of the European Network of Scientists for Social and Environmental Responsibility. So these debates are inside of science, and one can dismiss an organization of scientists for social responsibility and say they're bad scientists or they're subject to NGOs or whatever else. But note that that would be an asymmetrical argument because it would not invoke the fact that a lot of agricultural science is privately funded science paid for by Monsanto, and yet people don't talk about that in the same terms that they talk about the climate science, which is also bought by industry to some extent. All right, I want to finish up with a sort of general set of claims about the universalism of science. So a lot of these kinds of problems of trust rest on a foundation, a shared foundation, which we as children of the Enlightenment share about the universalism of science. And it's well to remember that after World War II, these themes came into play in a very major way, that science was equated with progress, with efficiency. I don't have time to talk about the little post-colon descriptions of what I'm talking about, but Science, the Endless Frontier, the 1945 manifesto of Vannevar Bush, is well known. So progress, efficiency, accessibility, eradication of hunger and disease, and transparency, that we would get cleaner development of all kinds of sorts. This was propagated through the UN as a kind of one world vision, through the expertise of the UN agencies, and it's summed up in this well-known quotation about nuclear power, which symbolizes the era's technocratic confidence. But you will note that some of the themes I'm saying are part of the universalist claims of science are built into this statement. Not too much to expect that our children will enjoy in their homes electrical energy too cheap to meter. So that electrical energy too cheap to meter is widely known and widely quoted. But Strauss went on to say, he went on to talk about famines. We'll know of great periodic regional famines only as matters of history, about travel, and about longevity. We'll experience a lifespan far longer than ours as disease yields and man comes to understand what causes him to change. So this is a statement about the apolitical nature of science and its capacity to better the human condition, wherever the human condition may be, not just locally, but globally. So that's not how everybody sees it. Strauss was talking about nuclear energy. This is from Germany. The only thing that is certain is risk. And that leads people like me to wonder about the ways through social institutions and processes that different societies construct their images of the future. And this is one of the final things I want to say to you, which I don't have time to get into in detail, but in my current work on sociotechnical imaginaries, what I'm trying to explore is a challenge to the claim of universalism. People do not expect the same things about science and technology, even when they respond the same way to whether scientists have prestige or not across different countries. What they think science is, how they think it ought to enter into their lives, and what particular areas of scientific and technological development ought to do for them. Visions of the public good and how science and technology ought to serve those visions of the public good do vary in interesting ways across cultures. This is from a comparison of nuclear power in the US, South Korea, and Germany. One notices very obvious empirical facts, like Fukushima happens. It has essentially no resonance in South Korea. Germans do yet another flip-flop and decide to phase out their old nuclear power plants, even though nobody thinks Germany is an earthquake-prone region or a tsunami-prone region. And the US is still talking about reviving nuclear power in a clean and controllable way. And so if you look at how these countries differ in their framing of risks and, of course, benefits, and what the stakes are, and how they define and frame public policy, what the nature of controversies is, and what the nature of closures is, you find quite radical and systematic cross-national differences, which suggests that we should not be addressing a thing like trust in science as if it is dislocated, as if it is a universal property of science or a universal property of culture. We have to get more specific, more particular, more localized in addressing our questions, and we can't divorce science from technology either. We have to think of that pairing as if they matter, because science enters most people's lives, not as science, but as technology, as an applied variant of the findings that may correspond in some basic way to natural phenomena. So these are the questions then that I want to end with, as I promised. I'm ending with questions, but the questions in a way are, where should we go next? And so the claim I would make is that over the 400 or so years that we've lived with a gradually increasing in size and scope modern science and its technological dimensions, in effect, we've created a set of unwritten constitutional suppositions about the relationship of science to the state, to the polity, to citizens, and to our lives. And I think the challenge for the coming century, if you will, is to undo some of those presumptions, or at least hold them up to the light of day. I sometimes refer to this as the second Enlightenment. The first Enlightenment did away with superstitions about nature. Today we have to do away with superstitions about science. And ask, what is this set of unwritten rules that we've crafted? And the answers will be different in different societies. So here are some of the sources of that unwritten power. What kind of authority does science enjoy in relation to other institutions of power? And again, I could give an entire lecture, an entire course about one very specific institution, the US courts, and deal with the answer, the multi-layered answer to this question as between science and the US courts. And one of the challenges for a science and society cluster is to have people who are doing this in every country. So what is that relationship between Canadian science and the Canadian courts? It deserves people to be looking at this in an ongoing way. What are the rules of conduct for science and of political accountability? And believe me, these things vary. Just the rules by which expert advisory committees are formed across countries that are otherwise incredibly similar to one another vary radically across countries. But what interests me is the underlying political theory, the underlying idea of constitutional regularity, governance, accountability, and even democracy that's embedded in these diverse rules for how you get an expert advisory committee to advise the government. What happens when this unwritten norm breaks down? We know from a couple of generations of sociology that not all social rules are written down, and in fact the most powerful rules may be the ones that are not written down. How do you all know that you shouldn't be whispering to one another while I'm talking? I mean, probably nobody actually gave you that rule ever, or that you should somehow be making eye contact towards me and not have your laptops open. I mean, there's a whole, my students, by the way, don't know these things. So, and Jason has been well, inculcated into a different tradition by now. But anyway, he looks at me often enough that I know he's not buying shoes. Anyway, so there are all these unwritten rules. They're part of this unwritten constitutional status of science. And yet it breaks down. So arguably, the way we should be thinking about the GM case and the climate science case is not from an all-knowing position of who is right and who's wrong, and all we need to do is figure out why the benighted people are wrong in this particular case, but rather to treat them as cases of constitutional breakdown, similar to constitutional crises that happen, particularly, something that I, coming from a legalistic culture of the United States, have always found fascinating, is how the UK knows when there is a constitutional crisis, given that they don't actually have a written constitution. So that it's that kind of unwritten rule where people have a sensibility that something seriously is breaking down that I think deserves investigation. So the project that led us to this room, or the projects actually, because now it's a confluence of things, and the hoped for future, this is in part about a perceived constitutional crisis, but I think we have to recognize it, hold it up, shake the dust off, and actually see what the elements of that constitutional crisis are. And then, okay, death of evidence, but, let's realize that evidence itself is constructed to be a thing called evidence. And if you don't believe that, go see Rashomon all over again and wonder what evidence is. And, so these are things that we have to think about. And then, because we can't avoid being a world polity, we can't any longer afford to be parochial. So the constitutional rules governing science-society relations in the United States, just to take the country about which I feel I can speak most authoritatively, those should not necessarily be imported over and overlaid on somebody else's society without examining it. If science really were universal in its own terms, apolitical in its own terms, value-free in its own terms, then, okay, we can bump it up to a position of global constitutional governance. But what I hope I've shown you, or at least pointed fingers at, is a whole set of nested arguments for why we should not buy into that surface characterization of the nature of science in relation to the rest of society. Once we've bought into that, it is decades of work. The Second Enlightenment may be a little faster in the era of Twitter than the First Enlightenment was, but nevertheless, it's going to take us a very long time to get to a place where we can buy into our sophisticated understandings of how institutions work, including scientific institutions, how they relate to other kinds of institutions, and how, above all, we as a global polity increasingly brought together by problems like climate change ought to go forward with respect for, but not undue deference toward, the findings of science in society. So thank you.
for questions, and I will try to keep an eye on hands up if you think you've been unjustly treated. Tough. So let's start, and I'll pass over the mic to you.
Hello. Thank you very much for your talk. It was like, you know, honey for my ears, because this is what I teach, what I tell. And my question is, what is your impact, the impact of your discourse on scientists? I mean, we are here between social specialists of science, and we agree that science is a social discourse. But how do you manage to break into the epistemic community, you know, or scientist? Are you treated as a researcher, as an intellectual, or as someone that does not understand what real science is, you know? You understand what I mean?
Yes, I understand absolutely what you mean, and it's a very important question. And in my personal life, in my institution building efforts, I have had more support from scientists and engineers than I've had from any other academic discipline, and this is now true for 2 universities, both Cornell and Harvard. So at Harvard, the former dean of engineering is one of my closest colleagues, and for the last 4 to 5 years, we've been hiring a postdoc together to work between us, and he has become completely convinced that STS ought to exist somewhere in the Harvard spectrum as a field of academic engagement, and he's become persuaded of this through this kind of collaborative work. I also have very strong support from the Harvard climate science community and environmental community in general. Now, and at Cornell, which formed a new department of science and technology studies in 1991, the lineup at the upper reaches of the university at that time was that the president was a scientist, the provost was a scientist, the dean of the college was a scientist, and the head of my program before I joined it had been a scientist. And they all believed firmly that science, technology, and society was a field that needed to be investigated. And I will say that the foremost spokespersons for that view, who themselves were public scientists, they'd been in Washington and places like that, they thought that it should be a professionalized field. I still remember the person who founded the STS program at Cornell telling me when I became director of that program that this was their vision. Their vision was that eventually someday there would be professionals like me who made this their area of study, and this is how they evolved. Now that said, I don't think that my eminent scientific colleagues who have personal trust in me understand what the field is trying to say. That is a different challenge, and it's a challenge that I think we have to recognize. So I think that behaviorist accounts of science do not carry weight with scientists if you deny the reality of their normative commitments. So if, for instance, you are not a Mertonian, who they can understand and they buy into because this is the ethos of the practice of science that they've learned, but instead are an early Latourian and say, look, what scientists are doing is playing games with inscriptions, all they're doing is producing these things, and you know, it's power that carries it and not the truth value. And above all, the subjectivity of the scientist doesn't matter in those accounts. Those read to scientists as, or at least scientists that I know, quite widely as, you know, insults in almost the physical sense of an insult. So to some degree, I find myself defending the field against some of its more catchy but necessarily reductionist accounts. In some sense, I find myself choosing a different discourse. I mean, so what hasn't been done, Sergio, is the whole field of STS communication. I mean, there's a lot of work invested in science communication and how scientists should speak clearly and simply and directly and avoid on the one hand and on the other hand, and sort of learn that people don't understand probabilities, so you should talk about a drop of alcohol in a bathtub and not 1 in a trillion. I mean, you know, these kinds of sort of toolkit things that scientists are taught about how to communicate ideas to the public. Well, there is, of course, some truth to that. I mean, you know, we talk differently to people who we think are strangers versus people who are close kin, differently to children from the way we talk to adults, you know, so on and so forth. So I do think that STS scholars need to pay attention to, you know, not the need to simplify. This is where I get annoyed. It's not about simplification. It's about encouraging understanding. I mean, so how do you evolve understanding with another person who you know is coming with different views from yourself? And I think that that is, it's an ongoing struggle. I've got to the point where some of my scientist colleagues, I can give them some of my writings that I do explicitly in the science press, like occasional pieces in Nature or Science or whatever. And, you know, it's partly to field test those items to see if they work. But those are written in a conceitedly different style from the things I write for academic social science use. And when I was hired at Harvard and there was a debate about whether I was too dangerous, I was told that 2 different people, one who favored my appointment and one who opposed my appointment, I wish I had been there. They were doing antiphonal readings from my own texts. She said this, but she said this. And then one person apparently said, well, she writes differently for scientists from what she writes for social scientists. Well, anyway, I mean, it's you know, it's an object lesson in how it's not an easy row to hoe. But the general proposition that science and technology operate in society, are themselves social institutions and deserve study, for that I've found wide resonance among scientists and engineers, wide and unwavering. It's the content of what you find out when you get there that is sometimes a bit more controversial.
Tom Peterson from University of Victoria. I direct the Pacific Institute for Climate Solutions, so I'm very interested in anything climatic. And in one of your earlier slides, you showed a survey, temporal time series from 1974 up to almost the present, showing the progressive decline in the conservative view of, like, essentially the trustworthiness of scientists, whereas the liberals were at least constant or perhaps slightly going up.
Right.
Can you explain why that's happened and how that's happened in the United States? What the forces were that have driven particularly the conservative element toward that progressive decline?
Well, I have theories about it. So I think that the decline among conservatives is partly what STS scholars would understand well, that is a growing perception that science is not disinterested. To be sure, this is not symmetrically applied, but it's pretty widely understood that if you once discount the trustworthiness of a witness, then you end up not believing anything that's coming out of that witness, regardless. I mean, then, you know, you can have yay good evidence. The best case I know about this, a sort of folktale kind of illustration, is the long, long trial of O.J. Simpson in the United States, which resulted in a jury verdict. The jury deliberated, as I recall, less than an hour. I mean, it was something ludicrous after 10 months of trial, and they exonerated him. And the evidence was pretty compelling. And people said, oh, they don't understand science. But I think that a far more fundamental threshold decision had been made, that LA people, especially people who were African Americans, did not trust the Los Angeles Police Department. So the LAPD had walked onto the stage as a corrupt witness to start with. Nothing they said could be believed. And therefore, there was this long trial. But at the end of it, none of it mattered. I mean, just none. they had decided that this was a racist attack on one of their own, and they exonerated the guy. So, you know, I think that with the conservative backing off, the perception that scientists are Democrats on the whole, which is true, by party affiliation, that they benefit from large science budgets, that they hobnob with the people who favor big government, and that big government in this case results in all these displacements that disempower people where they sit. These things, I think, are all extremely important. If you read the blogosphere, the charges that these scientists are corrupt and that they're in the pay of, you know, pro-climate interests, that's very, very widespread. I haven't myself done the quantitative research to count how frequent or when this emerges as a theme, but I do know enough about that part of the blogosphere to know that this is a charge that emerges. And I think that once you undercut the disinterestedness of the science, then you're really up the creek. This is partly why I insist on the democratic virtues. I mean, this is partly why I want to say, look, don't stand only on the view that you are rendering the best science. Indeed, the best science got to be the best science in its own history of the Enlightenment by imitating the procedures of the law courts, of the common law courts, and holding up through a process of wide testing before the public, the fact that people bought into the story because it seemed credible in a public light. So, you know, remember that heritage of empirical science and the experimental method sort of calquing itself on the back of common law, and not to forget that accountability matters at the end of the day. And therefore, I'm happy to go far out on a limb to say, look, democracy has been inventing these procedures of accountability. If you don't like them, quarrel with them, say what's wrong with them. But once we've agreed to these procedures, if we find a scientific body that is conceitedly expert, conceitedly representative of the right fields, but also adhering to these virtues of openness, transparency, critique, etc., then, you know, they've earned a multi-layered claim to trustworthiness. But don't forget the democratic virtues and only insist on epistemic superiority, that you're constructing this knowledge that is not, you know, given to others, because that rug can be pulled out from under somebody by showing interestedness, and interestedness takes many forms. For people who think that the Affordable Care Act in America is corrupt, those people don't think that industry funding is the corruption. They think government funding is the corruption. So you can't rely on, you know, NSF's funding or the DOE's funding to rescue you in that context.
Thank you, Gordon. Well, I'm interested in the concept of accountability. And I think very few people would agree that we want accountability, that power should be matched to accountability. This is really not controversial. But when you look at accountability is implemented, for example, in a federal government, it often basically comes down to many rules, a lot of performance measurement, a lot of effort in building the indicators, a lot of bureaucracy in delivering the information, the evidence for accountability, sometimes leading to I believe, a perverse effect where people become risk-averse, motionless, and basically refuse to use the power they may have because they rather be accountable, you know, not be accused of abusing accountability. So how do you implement accountability in science without having this negative effect of massive bureaucracy, massive oversight, and so forth?
Thanks for the question. So, you know, I don't think that STS is a field that can or should attempt to solve all problems of modernity that we have known deeply since Max Weber at the very least. And I think we should work with people like organizational sociologists and people who study innovation in firms and so on and so forth. So I think that the territory that STS people can reasonably hope to speak with special authority about is the epistemic and the artifactual and technological that goes with that epistemic as well. So that organizations develop tunnel vision and so on and so forth is sort of widely known and not something that we can cure, but to the extent that STS, because of its concern with the epistemic domain, has talked about the uses of reflexivity, the thinking about the assumptions underlying. There are places in institutional behavior where we can talk about what degree of reflexivity. So while I have not served in government and have no desire to, I have served on many, many National Academy committees, including committees that supervise risk assessment and risk regulation. And of course, that is a primary domain where you see the kind of paralysis and the kind of tunnel vision that you're describing. And one of the things that I've tried to do in those committees with my allies, my natural allies in those committee structures, is to think about how to push for reflexivity. So there was a report in 1996, for instance, which was conceitedly built as a rebuttal against the 1983 report that said risk assessment first, then risk management, then risk characterization and risk communication, and et cetera. Instead, it called for an analytic deliberative approach, and the report stressed that all analysis is based on framing, and that at times it would be necessary to go back and look for reframings. And then later there was one report that was produced more under the aegis of the Clean Air Act that was called something like Science and Judgment in Risk Assessment. So if you look at those reports, they're at least out there as documents that say that revisitation is necessary in some ways that have to be proceduralized. And of course the question was, well, when and how much, and isn't it too costly to go back and revisit everything? And yes, one has to have answers to that. Those are not particularly STS answers. I mean, and so yes, indicators. I mean, of course, there's, as you know, a whole branch of STS that studies the role of indicators. And maybe we should not, as STS scholars, get fixated on the piece of indicators that we have become very good at studying, namely how indicators reduce the world of complexity to render a simplistic measure, which sometimes has perverse consequences. Maybe we should also devote some of our very considerable energy to thinking about the consequences, which are not just perverse because they remake the world in their own terms. That's, again, a well-understood phenomenon, though not well understood to everybody. I mean, well understood to STS scholars, certainly, but also how indicators operate in an organizational setting. That would require more context-sensitive STS, going back to the roots of science in society, as opposed to just studying science for its own sake as a productionist instrument. So I think there's work for us, but in the end, organizational problems are not going to go away. It's a question of what kinds of people we train to be good diagnosticians of where the problems are setting in. Organizations are like bodies, and maybe you want to detect the knee pain before it becomes a full-blown candidate for knee replacement. So how you have the people sitting in the organizations who are capable of diagnosing the symptoms of pathology before they become full-blown pathological, here is where I think that coming with the kind of training that we might offer in STS might sensitize people. But I don't claim to have an arsenal of tools that will solve, really all the problems of modernity.
Thank you. Thank you very much for the nice talk. And because of the things, I'm working for an agency that funds research for development. And I was really interested in your comments, Africa, and the way sometimes it's very mechanistic, the way your science is applied to development. And it happens from a context where, we're talking about the US, the UK, or Canada. You have strong institutions that are communities that understand science, and they sort of debates. But when it comes, and I'm thinking on your last question here, in sort of context where those institutions are not present, but still, there is a drive in terms of using science as a sort of, this is a way for you to reach development, to address some of your problems, right? But when you have these kind of debates and the tension that you sort of express in terms of how do you conceive science and the role of science and citizenship, what would be the sort of reflections you would have in terms of linking then those actions into the development context where you have countries or areas where those institutions are not present, the communities are sort of weakly perceived or even trained in ways that we are sort of perceiving him becoming from units in the north, right? So I would like to sort of see maybe that's maybe not really a concrete question, but just trying to understand the sort of what you have.
Yeah, no, thank you. Well, I think it's time to actually drop the word development from our vocabularies because it just comes with so much baggage about the directionality in which you want to go. That somebody is developed and somebody else is developing, but that already sets up the linear scale of the directions in which you want to go. So, one thing that I'm saying is that there are styles of scientific activity and styles of scientific thought, and when people say they're applying science to development, that is not a neutral statement. You have to ask what style of scientific thinking are they taking out there. So there are places in our law and public policy, especially in international norms making, where we've recognized that there should not be, that we should not act as a world polity as if there's only one kind of way of not knowing. So in the Convention on Biological Diversity, the provision, not with many teeth to be sure, but nevertheless the recognition that indigenous knowledge should be given value and should be paid, and that extracting that value through a particular style of scientific production that depends on first reduction and then reintegration of that reduced knowledge, that this is not the only way to do it, that there are actually more holistic ways of knowing that may not propagate in the same way that modern science does, but that are entitled to respect anyway. I've had one eminent biologist in India complain about the Indian government's public policies towards biotechnology, saying that what this is doing systematically is dismantling the kind of knowledge and the kind of biological research which was much more based on whole systems knowledge in favor of running after somebody else's science, where India will never catch up because it doesn't have the labs and doesn't have the resources to innovate with the most specialized instruments and the most specialized labs. And he was saying, in the meantime, we're letting go of the kind of knowledge that we have been able to gather by having, in essence, public naturalists who are doing collecting on a wide scale. And so we're in danger of having neither the one nor the other. And what is that the result of? It's, in a way, the result of development. And it's the result of saying that agricultural development should follow the path trailblazed by Monsanto and not by some other means of agricultural intensification or biodiversity preservation or what have you. It's easy to say that there are multiple rationalities and multiple ways of knowing. It's very difficult to put into practice the kind of humility and modesty that would allow the successful modern science, which knows it's successful because it's conquered markets, not because it's conquered truths, but because it has also conquered markets and has money. It's hard to persuade that science that has not conquered markets and that's embedded in people and that's wrapped up in lifestyle is worth any respect whatsoever. You can go look at the STEP Centre in Sussex, run by the Institute for Development Studies and also the Science Policy Research Unit. It's now just called Science Policy Research, but anyway, SPRU, and look at their definition of pathways, which is a word that they have tried to revitalize as a theoretical term to suggest that if you cut into a society at a given moment, there are multiple pathways that could be followed, and that the story of development should be about maintaining the robustness of multiple pathways instead of focusing in on a single way as the best way. Again, this is at some level banal, but it's hard to put it into institutional practice when people have been taught that there is only this one right way, and it is the way that is all size fit, one size fits all for a very complex world. So I think development scientists ought to be taught technologies of humility, in my term.
We have time for a couple of more questions. And that. Or none. Excuse me. And navigate.
Hi, I'm Rick French, professor of business and public policy at the Public Affairs School at this university. I started out my career in STS 45 years ago, and I've sinned by following other pathways. I wanted to go back to the first question that you had, because I thought it was an absolutely critical one. And I want to ask you whether you think natural scientists, in particular, read enough STS. That's to say, they believe strongly in evidence, but they have very little evidence, by and large, it seems to me, but their own prejudices with which to address the questions of science and society that are at the core of STS. This does not stop them from pronouncing large categorical judgments and even cultivating cults of the kind that you mentioned with respect to the lack of recognition for science. I just wonder if you could comment on that.
Thanks. In the first way that you put it, do they read enough STS? The answer is no. It's actually difficult, though, as an STS scholar who is committed to her field, to figure out what to do about this. So a couple of years ago, I was successful in the very first and most minimal attempt at curricular invasion at Harvard. And now there's a graduate minor in STS. But there are no warm bodies other than me hired to run that graduate minor, and I can only teach so many courses. So I'm supposed to teach 3 a year. In fact, I've always taught 4, plus done extra advising for which I don't get credit, and so on and so forth. I just don't have time to teach more than, a third more than I'm supposed to teach. Okay, so these young scientists who are very eager to do STS as a minor don't actually have what I consider an ideal course through which they can get led into thinking about STS more broadly. They can take my Science, Power, and Politics graduate seminar, but it's pretty hardcore. It's hard going for people who've not read anything social science-y, since probably they were seniors in high school and maybe not even before that. So it's not ideal, but every year there's at least one young scientist who just laps up the stuff, says that this changed their lives and changed their ways of thinking. So I keep hoping that there's going to be some sort of fractal effect as these people go out into the world and talk to their own. But I'm not joking about Second Enlightenment. It's a series of nested institutional structures and belief systems that are very, very powerful. And comforting as well. There's just so many places where we want to buy into the objectivity of things. When I want to do a little tiny lesson, I get students to list 10 times before they came to my class that morning that they trusted in somebody else's expertise. And it extends to all kinds of things. Once you get them thinking about it, they're not thinking about it because they don't realize that when they go into Starbucks and have the milk pitchers, and one says 2% and one says skim and one says whole, that what the sort of edifice of trust is. Why shouldn't Starbucks be diluting its milk? People do this all the time in all kinds of societies. Inspectors, well, we know that USDA can't even inspect its meat. You just think about the sort of structures of trust that have been built up, and then you're trying to get people to think in a sophisticated way. I began a recent article of mine with a quotation from George Eliot from Middlemarch that I've always liked about how if you have a keen sense and perception of all human life, it would be like hearing the grass grow and the squirrel's heart beat, and you would die of that roar that lives on the other side of silence. So I think, going back to your question, that modernity silences a lot of the squirrel's heartbeat and the sound of the grass growing. And in fact, we would be deafened. Mad people often hear too many signals.
Okay, the last question.
Hi, my name is Marjorie Lavies. Governments rely on corporate science to make many decisions, drug approvals, pesticide approvals, etc. The public is deeply suspicious, or a large faction of them are deeply suspicious of corporate-funded science. And the academic world is very conflicted on the issue of whether or not people who are funded by corporations are doing honest science or not. Can you shed any light on how that dynamic plays out or could play out, or how we might clarify some of those roles and responsibilities?
Again, thank you very much for that question. So firstly, I think that the first two questions that I'm wanting us to excavate under this question of the constitutional role of science would very much look into the kind of thing that you're talking about. So when people say that climate science is being bought by corporations, I don't think people stop to say exactly what you said, which is that there are lots of places where we actually have decided, as a matter of unstated public policy, that the government should not produce a certain kind of thing because we have chosen to say it's not a public good, right? I mean, so we've chosen to say that it's more efficient for a company that's putting a new product on the market to develop the science that's connected to that new product. Mind you, at least in the US, we have not said that those same corporations should pay a tax to produce public knowledge about stuff that is already out on the market. And in the 1970s, when we enacted a decade of laws saying that we should go back and revisit the dangers from already extant things that are out there, we decided that that was public good and public knowledge, and that public science should pay for it. And we gave industry lots and lots of rights to question it, as a result of which our Toxic Substances Control Act of 1976 was completely emasculated, because industry constantly questioned EPA's threshold judgment that there actually was a risk enough to warrant asking industry to produce more knowledge about the chemicals that are already out there in circulation. And here it is 2013, and we're still fighting that same battle over the fact that the Europeans have adopted a different and more demanding standard for their chemical industry, and our chemical industry in the US is fighting the European REACH regulations because they go further. So I think all of that kind of stuff, I mean, you know, my questions are small questions, but there's worlds out there. I think in each society we need to get a better understanding. STS scholars need to, but also scientists and engineers, of the very schizophrenic ways in which we have parceled out public and private, and what we consider to be public, what we take to be the public good. People are always astonished. I find my young students are terribly astonished that the vast majority of the things that they use on a daily basis have never been tested. You know, somehow they've grown up with this comforting assumption that whatever they touch has been tested. You know, so every garment, every backpack, every, you know, seat in an airplane, you know, they think that there's this testing apparatus. But then if you go to the public and say, pay for these things, then, you know, it's a conflagration because it's big government and so on and so forth. So, you know, there's really a sort of huge amount of lack of understanding about where we've positioned science and technology in relation to the dispersal of what we take to be public and what we take to be private. I mean, I'll just conclude by saying that when BP came in and wanted the University of California, Berkeley, to do research on biofuels, and it turned out that they wanted a degree of control over things like appointments and first rights of review of research that was coming out. And a lot of people at Berkeley were extremely incensed at this development. The scientists themselves got up and said it was their freedom of speech and their First Amendment rights to get research money from wherever they could. So, I mean, you know, I was very glad that it was my student who was trying to fight this battle at Berkeley and not me, because I think I would have become apoplectic. But, you know, what it speaks to is why I use constitutional language. People themselves are using constitutional language, but with very little understanding of what it is they're talking about and what the underlying political theory is of where the public sphere should begin and end, where the private sphere should begin and end, and how the flow of knowledge across domains should be parceled out. The responsibility to produce, the responsibility to test, the responsibility to raise accusations if need be, who has the responsibility to pay when there is a legitimate doubt, and which institutions are going to operate on what basis. You know, in the Supreme Court of the US, we have court decisions that are not sensitive to what they're actually sorting out when they say this is a decision about evidence. What they're sorting out is the shape of the public sphere in the year 1993 and beyond.
Great. Thank you. I'm going to hand the mic over to my colleague Mark Sainer, who's going to thank you for opening our symposium in a wonderful way. Take it away, Mark.
Thank you. Well, actually, I'm just here to give you a small gift. But I really have to say that you managed to address the big picture and also do it very precisely. So you actually somehow got around this problem of the holistic and the specialist. And you did give us not all the answers, but very many. So thank you very much. And this is just a small thing for the airplane. So I just... do you want to do it later? Or don't you want to say about rooms and... okay.
We'll just have a 15-minute break right now. And so after the break, the session A will take place in this room, and session B will take place in the next room. And that'll be the logic for the remainder of the event. Okay, thank you.